In this lesson, we're looking at various laws of logarithms. So these would be laws that you could use in order to simplify an expression involving logarithms. Perhaps you're solving a logarithmic equation or solving a word problem involving logarithms, that type of thing. So the first law that applies to logarithms is the product law. And the product law tells you that the log of a product, in this case xy, base a, can be rewritten as log x base a plus log y base a. So when working with the product law, we need to remember that the law states addition. So, for example, I could rewrite log 9 base 5 plus log 3 base 5 as log 27 base 5, so 9 times 3. And similarly, if I have a product like 4x within my logarithm, I can break that apart and say this is log 4 base 3 plus log x base 3. The quotient law tells us that when we are dealing with a quotient in a logarithmic expression, we can split that apart and write that as log x base a minus log y base a. So for example, if I have log 9 minus log 6, that is equivalent to log 9 over 6. The base for this one, of course, is 10 since it's not written. And in part B, I could rewrite this one by breaking it apart and writing it as log x base 4 minus log x plus 1 in brackets base 4. The next law is the power law. And the power law tells us that when we have a power in our logarithmic expression, we can take that exponent and move it to the front of the logarithm. So log x to the exponent n base a is the same as n times log x base a. So for example, I could rewrite log 3 squared base 4 as 2 log 3 base 4. And I could rewrite 4 times log 2 base 5 as log 5 2 to the exponent 4, which would be equivalent to log 16 base 5. And the last law I'd like you to be familiar with is the change of base formula. This is the one that we will be using most often out of these 4. The change of base formula tells you that log m base b can be rewritten as log m divided by log b. So for example, I can rewrite log 10 base 5 as log 10 divided by log 5. Now the advantage here is that I can then use my calculator to evaluate both of these logarithms because now they're both common logarithms. They're both base 10 logarithms. So typing that into your calculator, you should get an answer of approximately 1.43. Next one, log 1.08 base 3 is the same as log 1.08 divided by log 3. And with your calculator, you'll see that's approximately 0.07. And log 125 base 1/2 is the same as log 125 divided by log 0.5. And if we put that into the calculator, we'll see that's approximately negative 6.97. Okay, so in example 5 here, we're asked to solve for x in what looks to be sort of a complicated logarithmic equation. But what we're going to do is apply some of our laws of logarithms here in order to simplify this and eventually solve for x. So on the left-hand side of the equation, notice that we have this value 4 in front of our log x base 2. So I could apply the power law and rewrite this as log x to the exponent 4 base 2. And on the right-hand side, I could use my product law to rewrite this one as log 81 base 2. And so now I have a logarithm on each side of my equation with a base of 2. So we're saying the exponent we put on 2 to get x to the exponent 4 on the left-hand side is the same as the exponent we put on 2 to get 81. So if that's the case, then x to the exponent 4 must equal 81. And therefore we know that x is the fourth root of 81, which is 3. And that concludes this lesson, very short one this time.